Welcome, everyone, again to another afternoon session of the Data Summit Connect 2021. And you are watching Track C, Session 105, Observability of Data Pipelines, with Julian Ledem, who is the Chief Technical Officer of Datakin. Julian is also the co founder and he co created Apache Parquet and is involved in several open source projects, including OpenLineage, Marquez, Apache Arrow, Apache Iceberg, and just a few others. And he can also, for those that are on Twitter, you can follow him on Twitter with his handle at J underscore. Makes it very easy to remember. So take it away, Julian.
Hello, I'm Julian Ledem. I'm the CTO and co-founder of Datakin, and today I'm going to talk about data lineage and observability with OpenLineage. So first, to go over the agenda, I'll talk about the need for metadata and what problem we're solving. Second, I'll talk about OpenLineage, which is an open standard for lineage collection, and Marquez, its reference implementation. And I'll end up with giving an example of building observability for Spark with OpenLineage. But that applies as well to SQL-based data warehouses like Snowflake and BigQuery and Redshift. So first, I'll start with talking about the need for metadata and really what's the problem that lineage and metadata is solving. So very often, when building a data ecosystem, you have many teams consuming and producing data and depending on each other. And often within a team, people understand their dependencies and they have like common practices and so on. But across teams, that's often where the friction starts, right? Like teams may follow different practices, they may have very little visibility on how data is produced and where it's coming from, and if there are multiple levels of dependencies, right? You may have a team that does the ETL and also a team that does analytics or build dashboards. It could be a team doing machine learning and various problems like that. And so to build a healthy data ecosystem, you need to build the visibility and the tools to enable understanding how they depend on each other and what's happening. And that's how you make those healthy, agile, fast-moving teams that can build things quickly without like having a brittle dependencies. So today, a lot of that friction is caused by this limited context people have around data, right? So you have data set coming, but it's often unclear what's the data source, what the schema, how is it evolving, who's the owner of a data set, how often is it updated, how often should it be updated, where it's coming from, what data set is it derived from, and who's using, and then when you're looking at the data you produce, you may care about who's using the data, and at the first level are multiple transformations removed, and track how data changes over time. And so, we talk about all that friction, and often we talk about how data engineers and data scientists spend a lot of their time cleaning up data instead of, getting value out of it. And so there's really this Maslow hierarchy of needs is a good parallel here. So the Maslow hierarchy of needs talks about before you want to reach happiness, you need basic things, right? The basic foundation of each human being is to have food and shelter, right? Like this is the basic stuff just for survival. And then the second level is we need to have safety, right? And so on. And so you have this hierarchy of basic needs. And then once those are reached, then that's where people can achieve happiness. And so in the data world, there's this very similar aspect of before you can get any value out of your data, first, it needs to be available, right? It needs to show up at all. And second, it needs to be fresh. It needs to be updated on a good schedule and it be fairly recent, right? And lastly, it needs to be correct. The data needs to show up, it needs to show up on time, and it needs to be correct. And once you have this strong foundation, that's where you can have your head above the water and you can start looking at, how do I optimize my business? How do I find new business opportunities? How do I really derive value from that data? And often people, are stuck in the three levels, basic levels, and they don't get that much value of their data because they constantly have to deal with it being broken, being showing up late, or invalid data, right? So you need these three layers to build trust in data. And so that's where that OpenLineage comes. And really with OpenLineage, we're trying to address this visibility and getting all the context we need. And so we were very honored to be joined with a lot of key contributors in the data ecosystem to start the OpenLineage project. So this is really a group effort when we got together and discuss how do we create a standard for lineage collection, lineage and metadata collection, and really solve this problem of understanding how data flows through our data ecosystem. So the purpose of OpenLineage is to define an open standard for metadata lineage collection by instrumenting data pipelines as they are running. And so in another way, this is to say that OpenLineage is the exit for data pipelines. So nowadays, when you take a picture with your digital camera or with your phone, it's going to encode metadata in it, like the coordinates of where you took that picture, when you took it, and so on. And that gets encoded with the picture, right? Like the best time to remember where this picture was taken is at the time it was taken. And so OpenLineage is very similar. It's about collecting this metadata as the jobs are running and be able to encode in a standard way all the information that is available at the time this data is being produced. And so, and it solves a common problem, right? Like there are a lot of projects that are care about collecting data, right? Like there could be a Munson, Data Hub, Marquez, Atlas care about collecting metadata in Lineage, right? And they all have, for all those projects, there's lots of duplication, and then they all need to extract this lineage and reverse engineer all those projects that inherently contain lineage and metadata. Could be if you're working in a Spark or Pandas ecosystem, or it could be in the scheduler like Airflow, or it could be in a data warehouse like Snowflake, BigQuery, and Redshift, or like more like SQL and Hadoop type things like Hive and Presto. So all those things inherently contain lineage of like you're reading from this data set and writing to this data set, but it's not exposed in a standard way. And so all those projects needs to extract this information. There's lots of duplication of effort. And at the same time, it's very brittle because as all those things evolve over time, the way they represent lineage may change, or like this metadata may change, and we need to maintain those integration for all the versions of all those things. So the goal of OpenLineage is two ways. One, by having this effort shared and standardizing it, we can remove the duplication and share this effort on building this integration. And second, since OpenLineage is a spec, right, it doesn't imply anything on how this metadata is collected or stored or used, it can really easily be pushed into each of those projects and really invert that dependencies in that each project can implement OpenLineage to represent metadata in a standard way while and while not having a heavy dependency, right? It's basically just an interface that you implement, and then it can be configured to send this metadata data to various repositories. And so to give the scope, right, there's really a parallel between OpenLineage and OpenTelemetry. OpenTelemetry is this project that achieves similar things for services, understanding dependencies between services through traces, and also collecting metadata and through metrics, right? So OpenLineage does the same thing for jobs and data set in this transformation ecosystem. And it's really focusing on standardizing the metadata, enabling the integration, and having a generic backend that can send those events, right? And it's not focusing on storing the data, leveraging the metadata and things like that, like things that the Marquez project or things like Data Hubs, Munson, Atlas, Egeria might be interested in. And the core model is really a JSON schema spec. So metadata is sent in JSON over the wire. It's specified by its JSON schema. And a key part of this is consistent naming of jobs and dataset. That's how you can stitch back together the lineage by having a standardized naming. How do you name a dataset? How do you identify it? And second, it's very extensible because once you define this lineage of there's a run of a given job and it's for reading from those datasets and writing to those datasets, then you can attach metadata under the form of facet to those core entities, right? And a facet is an atomic piece of metadata you can attach to either a run or a job or a dataset. And I'll go to that in more details in the next slide. And then those events can be sent asynchronously over a medium, right? So OpenLineage doesn't make any assumption except that it's asynchronous, so it's able to send an event and not have to wait for an answer on any sort. So you can configure a backend. Today you can obviously post those events over a HTTP endpoint to Marquez, for example, but it could be Kafka or any other configurable asynchronous protocol. And now, as an example, the type of event you would send is like a run start event with a source code version and the run parameters, for example, followed by a run complete event that may contain the input dataset, the output dataset version that were produced and what was the schema at the time they're produced, as an example. So this notion of facet is really meant to be extensible. So you have this core lineage of a run of a job, reading from dataset, writing to dataset. But then the facet is what allows to extend all the information around it. Because a dataset could be a streaming dataset in Kafka, or it could be a batch dataset, could be a table in a warehouse, or it could be a folder in a distributed file system. And a job similarly can be a SQL query, it could be a batch job in Spark, and it could be a streaming job. So facets are a good extensible way to handle many different types of datasets and job, and to attach facets of information to them, and like what was their schema, what was the definition of the code, if it's a SQL query, the query, and so on. And it's also enabled decentralizing the definition of the metadata, because you have core facets that are defined part of the spec, but it's also allowing custom facets defined by each of the system caring about defining things, which allows you to define your own custom facets and to define your own version of what the metadata is and understand where you're at. Sorry. It lets you define your own custom facet that clarify what are certain things from your own perspective, and lets you define facet without having to go through centralized approval process, right? So under your own prefixes and your own namespacing, you can define your own facet and attach your own perspective or specific type of data, metadata, even if it's not part of this core spec. And it lets you extend the core model and have this decentralized way of adding metadata. And so to give you an example of facets, in a data set, you may have like statistics, like data quality metrics. You could have the schema. What was the version of the data set if you're using a version storage like data lake or iceberg, or even column level lineage. At the job level, you may have the source code. Like if it's a SQL query that's self-contained, you could have the SQL in there. You could have the dependencies, the parameters, the hyperparameters that were passed to the job. Where is the job stored? What was the query plan? For example, at the run level, could have the schedule, a batch ID, a query profile, as example. And so if OpenLineage standardizing the definition of the metadata, Marquez stores this metadata and keeps track of all the changes. And so the way you would deploy that, and you may have like your Marquez instance that stores all the metadata, and you instrument your data platform. So here I'm giving an example of a data platform, from the ingest to the storage, compute, and BI dashboards of machine learning. And often you have a streaming layer and you have a batch layer, and you might use different tools for compute, whether in streaming or batch. And here I'm giving some examples, but people use different systems. And then you use Marquez to centralize the collection of all the metadata once it's been instrumented with OpenLineage. And to give an example of what the Marquez data model, if OpenLineage makes observations about the running jobs, there's a run of a job, and this is what it's reading from, where it's running to, and this is what they look like at this moment. Marquez will keep track of all the changes, right? For every new run that comes in from OpenLineage, is going to keep track of whether the job version has changed, is going to keep track of what dataset version it read from, what dataset version it produced, and keep track of all the changes in metadata. That way you can go back and look at when the job has run, what had changed compared to the previous run of the job, right? Is it the same definition of the code? Can we correlate the change in the job definition with the change in the dataset? And so, and then what Datakin builds on top of that, right, is deeper analysis and leveraging this metadata to do better understanding of operational dependencies, do impact analysis, do troubleshooting, what has changed since the last time this worked. And when Marquez and OpenLineage standardize metadata collection, when did the job run? What were the parameters? What versions have the input and output it consumed? So all that is standardized and collected in Marquez. And in Datakin, we can do deeper analysis on top of that same data. And so to give you an example, here's how Spark observability works with OpenLineage. And again, this is an example. OpenLineage integrates with SQL warehouses as well. And so typically in a data processing environment, you have a mix between batch jobs, Spark jobs, like streaming job, like SQL warehouse, and using different type of technology, and you want to bring down null in a similar graph. So taking the example of a Spark agent, it's simply by adding the Marquez Java agent to your extra Java options, which is going to add a listener to your Spark context, which allows Marquez to see the logical plan and to extract the input and output of this, right? So the metadata that is collected includes inputs and outputs, and it also includes information about data volume that is available, as well as a logical plan, which lets you, if you need to debug and troubleshoot problems and figure out what happened, you can keep track of how the logical plan changed, how the size of the output dataset changed over time, and what dataset it was reading from and writing to. And so to give you a summary of what the model and how we model jobs based for Spark, for example. So a typical example is to use an Airflow DAG to run a Spark job. So you may start with the first step, it's spinning up a Spark cluster in the cloud or somewhere. Second step, we need to run the Spark job. And then finally, there's another step that tears down the cluster when this is done. And you may run multiple Spark jobs on that same cluster in between. I'm taking here an example of a simple example of often how this is done. And so when we model this, you'll have the Airflow job, like contains all the tasks. Each task is its own job in this model as well. So the tasks that create and destroy the cluster do not have lineage. And then when you go more deeply in the Spark job, a Spark job will actually have multiple actions. Every time you do an action in Spark that writes an output, for example, you will actually run a separate job. So within the Spark job definition, each action will be modeled as its own run in the OpenLineage model, which will let you keep track precisely of the execution of a Spark job. If one of the action fails, you'll keep track of which actions completed, which action failed, what run, and what didn't run. And so this is an example of what the lineage graph looks like once it's collected. So this is the kind of lineage graph you can collect, and you can see each box would be a separate Spark jobs with a couple of action, and you understand how the data dependency work here. And another example of what we can do, since we're collecting the output size, you can start looking at how the output size of the job varies over time, right? How many rows have been produced, which can also help investigate when suddenly, the row count drops. That could be a sign that something is wrong with the job logic, right? And you'll be able to correlate when the number of rows drop, for example, with has the version of the job changed at the same time, or did an upstream change cause this? And so this is really useful to be able to track data volume evolution as kind of a coarse grain quality metric. It also helps with debugging performance issues where suddenly the data volume increases and cause a job to run much slower. And so to finish this talk, I would encourage all to join the conversation. If you want to learn more about OpenLineage or Marquez, you can join. You can go check on the GitHub page that would link you to how to join the Slack, where to follow us on Twitter, or join the mailing list for OpenLineage. So you're very welcome to join the conversation, come ask questions, or contribute or offer improvement to the spec. On that, thank you, and I'll welcome your questions.
Thank you, Julian. Very informative, and you've been definitely busy on GitHub and Twitter. We do actually have one question that came through from Mahesh from Selective Insurance. And Mahesh asks, what integration is available for proprietary tools such as Informatica Power Center?
So there's not yet an Informatica integrations. The integrations that are available at the moment, there's a Spark integration, Snowflake, Redshift, BigQuery, Airflow integrations. Of course, this is an open source spec, so like contributions are very welcome, and we are constantly working with people in the community who are interested either in consuming OpenLineage or in producing OpenLineage. And so, of course, it's a goal to have coverage for Informatica. And what was the other one, Chrissy?
Power Center.
Yeah, Power Center, but it's not there yet. But you're welcome to come discuss that on the Slack channel. I think that would be great to help build priority around those things too.
Thank you, Julian. Hopefully, Murs, that did address your question. And as Julian said, just continue that conversation in the Slack channel. I'll actually post those links from the slide deck, so you'll have the active links in the chat. There aren't any other questions, but now, Julian, you'll be heading over to the networking area, right? Or
yeah, that's correct.
Oh, excellent. So, for those that no, okay, Manish, appreciated the response. He said thanks. So,
You're welcome.
So for those that may want to just find Julian in the network area and then just engage with them with those conversations there, feel free. Or you could always find him on Twitter, right? GitHub and the Slack, and I think there was a Google chat, but I'll pull those links from the slide deck and post them in the feed loop chat. So people will have them. And And so far, there's no other questions. So we may just have people may end up with some additional time before the next session, or additional networking time for all those other questions. So I'll, oh, yep, I'll post the, let's see, the Slack channel for Marquez. There we go. There's that. And there's the Slack channel for OpenLineage. There you go. For the engagement. And I had posted the GitHub links earlier during your talk. Yeah.
And the GitHub link should also have links to the various community areas like the Slack, the mailing list, and the Twitter accounts.
Fabulous. Okay, thank you, Julian. And I'll just do a quick scan in case there's any other last minute questions. Nope, no other questions there. So it could be people are just eager to get over to the networking and just interact with you directly, Julian. So
sounds good.